Hi, my name is Allison Stevens. I'm the professor and coordinator of the Advanced Ergonomic Studies program at Fanshawe College. Thanks for joining me today. I wanted to talk to you a little bit about Process Simulate Human and its ability to do ergonomic analysis. I worked with this software and with the Siemens products for many years in my role as a technical specialist at Ford. So Campbell, please show us the simulation you've created for us today. So the capability of the software to create some simulations is very powerful. So we have here a lot of lifting applications. As you'll see, one-handed and two-handed lifts. The other thing that that the simulation is capable of is pushing and pulling, and then obviously analyzing them. Very realistic movements. You can also then get some idea of some times, and really a great proactive tool in the design of the workstation. So from here, she'll move forward onto the shelves. And we've chosen a 5th percentile female. Again, this is always a good size to choose because then you can decide if some of the heights within your work cell are acceptable. So we've got some shelves here that she reaches to. And obviously the cart that she's delivering. So the ergonomic analysis tool that I'd like to talk to you about today is the arm force field. Camilla, if you could go back to the beginning where she picks up the 10 kilogram parcel with one hand. Some of our earlier analysis, we showed that in a PDA that this was an element that might be of concern. So she's going to go back, pick this up. The arm force field is a brand new, I should say brand new, but relatively new ergonomic analysis tool. And I'm really excited that it's integrated into PS Human. Camel, if you could open up the menu for arm force, where we're going to analyze this posture and her lifting of this 10 kilogram weight. So the software pulls all the data right from the simulation of the 10 kilograms and moves into a menu here. We're going to choose the percent capable. As we have a female on here, we want to make sure that 75% of the female population can do this task. And that would then accommodate most of the male population. So we have 75% capable entered in. And Camel, I'm going to ask you to hit to evaluate this.
So now it is evaluating and takes a few seconds to do. Okay.
Okay. And so the way that this is actually evaluating it now, it says in the current scenario for 75% capable, that we are actually at a 10 kilogram load, and it is recommending a 9 kilogram load. Is that right, Camel?
Yes. It's a 10 kilogram load, and for the arm strength for this scenario is roughly 9 kilogram.
Okay, so that is telling us that 75% of the female population would be able to lift 9 kilograms. The load itself is 10 kilograms. So we know it is a little bit over than from our recommendation. Now, this is a static posture, a one-time event. What happens if we had parcel lifting at a higher frequency? Let's see how that has affected it. Camel, could you turn on the MAE equation, please? Our maximum acceptable effort. Here is where we're allowed to put in our frequency and the duration. Now, this duration is how long it takes us to actually grasp that parcel. So it's actually a very short duration in here, which is 0.2 of a second per effort. Okay, so we've chosen 10 of these parcels in a minute. She's a busy postal worker, we'll say. So, Camel, can you update the evaluation here? So at this frequency now, originally, if it was a one-time, it was 9 kilograms. It's now being dropped down to a 5 kilograms. So this now allows us to take a biomechanic static evaluation and add some fatigue, again, from the Potvin MAE equation, and recommending that the parcel limit then at this type of posture would be 5 kilograms if you're going to do a 10 frequency per minute. All right, thank you. And that really shows you the power then of the arm force field. Exciting to have multiple ways to analyze different tasks within a simulation.